Since different isotopes of an atom can have different masses because they have different numbers of neutrons, then the average atomic mass for a particular element is going to be the average of the atomic masses of the isotopes that occur for that element. Now, atoms obviously are very small, so it doesn't make much sense to talk about the mass of an atom in grams, and so there's a unit that's used for the mass when you're talking about masses of atoms, and that's the atomic mass unit. The atomic mass unit, AMU, is 1/12 the mass of carbon-12. So you take a carbon-12 atom and 1/12 of its mass is an atomic mass unit. That's how it's defined. So the average atomic mass is a weighted average of the isotopes. Now, it's actually very easy to compute with these kind of problems, so let's see how we do it. Copper, so we have copper, and let's say when you find copper, naturally occurring copper, then 69.15% of that copper is copper 63, so it has mass number 63. 30.85% is copper 65. And let's see, does that give us, yeah, that gives us 100%. So that's all of those are the two isotopes of copper. Now, the mass of copper 63 is approximately 63 AMUs. It turns out it's not exactly 63 AMUs. It's 62.929601 AMUs. That's actually the mass of copper 63. And the mass of copper 65 is not quite 65, it's 64.927794 AMUs, but it's really close. If you use the number 63 and 65, you'll still end up with almost the exact same answer. So to figure out the average atomic mass, you take the percent here, so and write it as a decimal, so 0.6915, and you multiply times the mass of that, which I'm just going to use 63 rather than that big one. So times 63 plus this as a decimal, 0.3085, times its mass, which is 65. So we calculate that. Okay, let's see. Point 6915 times 63 plus 0.3085 times 65 gives me an average atomic mass of 63.617 or 63.62. Which is very close to what I would have gotten if I had used these numbers. It's not exactly the same, but it's close. So that's the average atomic mass of copper. Okay, now let's talk about the mole and what the mole is. The mole is used to talk about the amount of substance. The mole is just letting you know how much of something you have in terms of numbers. And the mole is defined to be the number of atoms that are in 12 grams of carbon-12. That's just how it's defined. So 1 mole equals, it's a number. A mole is a number. The number of atoms in 12 grams of carbon-12. That's what a mole is defined to be. Now, it turns out that that number is Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23rd. So in 12 grams of carbon-12, there are 6.02 times 10 to the 23rd atoms. The mass of 1 mole of a substance is called its molar mass. Now you'll also hear it referred to, if it's a molecule, as molecular mass. Molar mass is a better term. I'm probably going to say it differently every time I do it, but it's the mass of 1 mole of a substance, and it's written in grams per mole. So, and you'll hear me say molecular mass or molecular weight. But this is what you're going to use. The molar mass is what you use for all kinds of different calculations. Because what's going to be important in chemical reactions is not how many grams you have, but how many moles you have, the number of atoms that you have. So, if you need to convert, if you have the number of moles and you want to get to grams, so to go from moles to grams, you multiply number of moles by the molar mass. So if I have 2.0 moles of helium and I want to know how many grams that is, I find out the molar mass of helium. Helium's right here, molar mass 4.0026. So there are 4.0026 grams of helium in 1 mole of helium. That's what the molar mass means. Your moles cancel and you get about 8.00 grams of helium. The key thing to remember is when you're going from moles to grams, you multiply your moles by the molar mass. That's how you do it. If I want to figure out how many atoms I have, so if I have moles and I want to know how many atoms I have or how many molecules I have, so to go from moles to number of atoms or molecules or whatever, you take your moles times Avogadro's number times 10 to the 23rd, and that's all you have to do. So if I have 3.6 moles of helium, then I have 3.6 times 6.02 times 10 to the 23 helium atoms. Okay, now the button on the calculator that is times 10 to the is this little EE right here. So I have 6.02 and then second and the comma. That puts the E up there. That E means times 10 to the, and then I put in 23. So I get 2.17 times 10 to the 24 atoms. Okay, so let's just summarize. To go, if I want to go from moles to grams, multiply by molar mass. If I want to go from moles to number of atoms or molecules, you multiply by 6.02 times 10 to the 23rd. Okay, well, given that, then let's figure out how to go the other way. Let's see, how would I go from grams to moles? to go from grams to moles, you will divide by 6.02. You'll divide by the molar mass. Okay, so if I have, let's see, 11.9 grams of aluminum, 11.9 grams of aluminum. To figure out how many moles that is, I'm going to divide that by the molar mass of aluminum. The molar mass of aluminum is 26.982. Molar mass is in grams per mole. If I divide grams by grams per mole, I get moles. So 0.441 moles. Okay, if I want to go from number of atoms to moles, I divide by Avogadro's number, 6.02 times 10 to the 23rd. So if I have 3.01 times 10 to the 23rd silver atoms, doesn't matter what kind of atoms I actually have, and I want to figure out how many moles I have, I take it and I divide, that's 10 to the 23rd, by 6.02 times 10 to the 23rd. .01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and I get 0.5 moles. Okay, now, so it's a one-step process to go from something to moles, or from moles to something. One-step process. Just to make sure we've got it, I have this way to remember it. So make a triangle. This is grams. This is the molar mass. And this is moles. So molar mass, that's what you look up on the periodic table. So if you're trying to find grams, then if you look at this triangle, you cover up grams, you know that you need to multiply molar mass times moles. So to find grams, multiply molar mass times moles. If you're trying to find moles, then if you're trying to find moles, you cover up moles, and that tells you you need to take your grams and divide it by the molar mass. So this triangle can help you remember which direction to go. Or you can just remember mass in grams equals molar mass times number of moles. Okay, so there's your equation. Easy enough. Fill it in. If you have the molar mass and the number of moles, multiply them to get the mass in grams. If you have the molar mass and the mass in grams, then you would divide the mass in grams by the molar mass. So this equation, if you memorized it, that's good. All right. And you can do something similar with Avogadro's number if you want to. Okay, so up here on top, you'll have the number of whatever it is, number of atoms, number of molecules, and down here you'll have moles, and this will be Avogadro's number, 6.02 times 10 to the 23rd. So if you are looking for the number of moles, you cover up moles, you take the number of atoms and divide by 6.02 times 10 to the 23rd. If you are looking for the number of whatever's number of atoms, cover that up, and that tells you you need to multiply 6.02 times 10 to the 23rd times moles. Or you can just remember the equation that number of particles equals 6.02 times 10 to the 23rd times number of moles. Okay, straightforward. If you know either this and this, or this and this, then you can solve all of those kinds of problems. Now sometimes you may have to use both at once, so we'll see an example of that. Okay, so let's say that our problem is, it's going to combine our two, and the question is, what is the mass in grams of 1.20 times 10 to the 8th atoms of copper, which is Cu. Alright, so here we don't have moles in our problem, but know that you always have to use moles. You can't get away without using moles. So if moles is not part of your problem, we have mass and number of atoms, this is going to be a two-step problem. We have to go to moles first. So we are given number of atoms, and we're trying to get to mass. But we have to go through moles. You always have to go through moles. So we have number of atoms. Okay, and I'm trying to get to moles. I always have to go through moles. I have number of atoms. So I'm trying to get to moles, and so this tells me that I need to take my number of atoms, which is 1.2 times 10 to the 8th, and divide by 6.02 times 10 to the 23rd. So number of atoms divided by 6.02 times 10 to the 23rd will get me the number of moles. So 1.2 times 10 to the 8th divided by 6.02 times 10 to the 23rd equals 1.99 times 10 to the negative 16 moles. Okay, so I have the number of moles, but I need to get to the mass. I'm looking for mass. Okay, I started with number of atoms. I'm trying to go to mass. I have to go through moles, so my first step was to get the number of moles. Now I take my number of moles, so here, grams, molecular mass, and moles. I'm looking for mass. So I'm going to take my molecular mass times my moles. So my molecular mass, I need the molecular mass of copper. Molecular mass comes from the periodic table. I find copper. It's 63.546. And that's in grams per mole. I multiply that times my number of moles. So I already have my 1.99 times 10 to the negative 16 on my calculator. Now I multiply that times 63.546, and I get 1.27 times 10 to the negative 14